Welcome to the Mechanical Engineer. In this video, we are going to see the concept of forces in space. Actually, in forces in space, two types of problems will be there. One is the forces will be given with magnitude and inclination. In the another one, the coordinates will be given. So this is the first one, that is the forces in space with magnitude and inclination. So here, a force will be given and three coordinate axes will be there. So x, y and z. So the force is an inclined one and it is inclined for all the three axes. So let me consider delta x from the x-axis, delta y from the y-axis and delta z from the z-axis. So in this type of problems, the force with its magnitude and the directions, that is the inclination delta x, delta y and delta z from each axis will be given. So now if these are given, I can write this force as a vector by considering the x-axis as I, y as j and z as k. So my force vector will be F vector is equal to Fx I plus Fy j plus Fz k. So here Fx is the component of force acting in the x direction and Fy is the component of force acting in the y direction and Fz is the component of force acting in the z direction. So generally we will split that into two components in case of the previous problems, horizontal component and vertical component. Here as there is three directions, we have split it into three components, Fx, Fy and Fz. Now to find out the value of Fx, I can construct a triangle here by considering this as F and the horizontal component as Fx and the inclination as delta x. So if I take cos delta x, then I will get Fx divided by F. So the Fx is equal to F cos delta x. So this is the magnitude of the horizontal component. So in this general equation, this Fx represents F cos delta x. Similarly, Fy, I'll get F cos delta y and Fz is equal to F cos delta z. So these are the three components of forces and this is the general force vector. Now, in case if I want to find out the value of delta x, then I can write delta x is equal to, we know that it is cos inverse of Fx divided by F. So here also, if it is delta x, then it is equal to cos inverse of Fx divided by F. In case of delta y, it is cos inverse of Fy divided by F. Similarly, delta z is equal to cos inverse of Fz divided by F. So these are the three components of forces and the inclination of each force. Now let us move into a simple problem. So this is the first problem. A force of 100 kilonewton is acting at a point making an angles of 32 degree, 100 degree and 60 degree with respect to x, y and z axis. Find the force vector. Now we know that the force vector is F is equal to, F vector is equal to Fx I plus Fy j plus Fz k. So to find the force vector, I need the components Fx, Fy and Fz. So starting from the given data, in the question, the magnitude of the force is given, that is F is given, it is equal to 100 kilonewton and the inclinations are given. So delta x is given as 32 degree, delta y is given as 100 degree, similarly delta z is given as 60 degree. So we know that the equation for Fx is Fx is equal to F cos delta x. So I'm going to substitute the values. The F is 100 and cos delta x is 32 degree. So the answer is 83.42 Newton. Similarly for Fy, it is F cos delta y, that is equal to 100 cos theta y is given as 100 degree, and the answer is minus 17.36 Newton. Now, going to the Fz, the equation is F cos theta z, that is equal to 100 cos 60 degree, that is equal to 50 kilonewton. So here also it is kilonewton because the force is given in kilonewton. Now to write the force vector, F vector is equal to, Fx is 83.42. So it is 83.42 I, then minus 17.36 J plus 50 K. So this is the final force vector. So here this is Fx component, this is Fy, and this is Fz. So the second problem is a force vector of F is equal to 10I plus 13J minus 12K acts at a point O, which is the origin. So here the force vector is given. Okay. Find the magnitude and direction of the forces. So we need to find out the value of the F, theta x and theta y. So let us start with the given data. So the given data are F vector is given, that is equal to 10I plus 13J minus 12K, which means that Fx is equal to 10, Fy is equal to 13, and Fz is equal to minus 12. Okay, so now let us solve the problem. We know that the F vector is actually the magnitude vector, and we know that the equation for magnitude vector is root of Fx square plus Fy square plus Fz square. So this is the general equation for find out the magnitude of any vector. So that is equal to root of 10 square plus 13 square plus minus 12 the whole square. So that is equal to 20.32 units. Because the unit of the force is not given, that is why I am considering it as a unit. Next, to find out the value of theta x, we know that theta x is equal to cos inverse of Fx divided by F. That is equal to cos inverse of Fx is 10 divided by F is 20.32. So this will give you 60.52 degree. So similarly for theta y, that is equal to cos inverse of Fy divided by F, that is equal to cos inverse of Fy is 13 and F is 20.32. So the answer is 50.2 degree. Similarly, the theta z is equal to cos inverse of Fz divided by F, that is equal to cos inverse of Fz is minus 12 and F is 20.32, that is equal to 126.2 degree. Now the magnitude of the force is 20.32 and the inclinations are 60.5 to 50.2 and 126.2. So this is how we can find out the magnitude and direction of the vector if the vector is directly given, or in the first problem, the inclinations is given and the magnitude is given. In that case, we can find out the force vector using this method. Thank you.